Assalamu alaikum. I'm Hamza from Mechatronics Department of AIR University. So today we are going to discuss microcontroller and embedded systems lab. This is lab number 3. Let's come to this lab. In this lab we are going to interface. So in this lab basically we are going to write a program in C, and we are going to discuss how to interface a 7-segment display with our Arduino. So here are different examples. In the first example, we are going to write a C program to send values from 0 to 255 to port B. So this is a program. Hashtag include avr.io.h. Using this command, we add the avr header file. Then this is the main body of the program, int main void unsigned char z. Then we are going to declare port B as output. Using ddrb command, we are going to give a direction to this port from 0 using 0 cross ff. Then here is a for loop which is going to run up to 255 times and storing the value in port B. In the second example, here we have to write a program to send hex values for ASCII characters of 0, 1, 2, 3, 4, 5, A, B, C, and D to port B. Again, we add the header file of AVR in the main body. We used mylist, in which we are storing 0, 1, 2, 3, 4, 5, A, B, C, and D. Then we have a for loop which runs for 9 times from 0 to 9. It basically runs for 10 times, but from 0 to 9. Then in port B, we have mylist, which sends the ASCII character of these letters and numbers to mylist and then displays them to port B. Then in third example, we have to write a C program to toggle all the bits of port B for 200 times. Again, we add the header file of AVR. In the main body, we declare port B as output, and in port B, we send AA. Then it runs for 200 times, and using this negation sign, we are going to toggle port B. In the last, let's come into the last example. So in the last example, we have to monitor the 5th bit of port C. If it is high, we have to send 55. Otherwise, A to port B. So again, we add the header file. In the main body, we declare port B as output and port C as input. Then we have a while loop which checks the 5th bit, which is a 6th bit of pin C. If it is 55, then it means it is high and sends 55 to port B, else it sends AA to port B. So here are our main activity. In the first task, we have to write a program that takes input from port B and checks whether the number is even or odd. If the number is even, then blink alternate LEDs of port C with a delay. If the number is even, then blink LED at port C one after another from least significant to bit to most significant bit. So coming to its program, AVR code. This is AVR screen. So here we have the AVR code for task 1. First we define the CPU speed, then we include the header file, then we include delay. Using DDR, we declare port B as input using 0 cross 0 0, and using 0 cross FF we declare the port C as output port. Then we use the while loop, which checks as we initialize port B as input, so it checks the bit of port B. If it is on, then LED blinks from least significant bit to most significant bit, and here we use the delay. If it is even, then LED blinks for alternate times. So it is the AVR file. Now coming to its Proteus. Let me open Proteus. Sorry. So we have the Proteus. Let's upload the hex file. So we have uploaded the hex file. So as here we have the even input, so it is toggling the alternate bits, and for odd it is going to toggle the next bit. So it was our task 1. Now let's come to the second task. So this is the second task of lab 3. We have performed this task in lab as a group. Let me show you the second task. In the second task, we have to monitor the fifth bit of port C. If it is higher, then it should send 55 to port B. Otherwise, it should send AA to port B. Now, let's come to the program. First, we declare the CPU speed, then we add the header file, then we add delay. After that, we add a display function in which we store the values for the 7th segment. This is basically according to the data sheet as we have seen from the internet. Then we declare port A as output and port B as output, and we are going to monitor the bits. Then we have the delay function. So this was the code of task 2. Now coming to its Proteus. So here we have the produce file. Now uploading the code using hex file. We have we have uploaded the hex file, and this code is basically the code of counter, and we can see that here we have the counter produce file of the counter, and we can see that the counter runs from 0, and this is the code for the counter. We have the task was basically to send, let me show you, to monitor the fifth bit. This task is basically the task as I have explained earlier. The task that I showed you is basically the third task in which we have to make a counter, and you have seen the program and the Proteus file of the counter. So coming to the next task, let me show you task 2, and this task is now basically task 4. We can open task 4 Proteus. So it is a task. We are using a hex keypad, and the input which we pressed here is displayed on the segment display. Now first we upload the code, then I will show you the code and its hardware. Here we have task 2 hex file. So as we can see that I have pressed 2, and 2 is displayed on this 7th segment display. Then I pressed 5, and 5 is displayed on the 7th segment display. Now let me show you the code. So here we have the code in which first we set the CPU speed, then we add the header file, then we add the delay library in the display function, then we have display function, then we have a 4x4 keypad, and in the keypad we have these 0x07. From datasheet we have added the hex numbers for the character 0, 1, 2, 3, 4, 5. These are the hex numbers 0x07. 07 is basically for 0, and in the same way I added all these numbers. In the main loop I give the directions. For port A we have output, for port C we have input, and for port B we have output. And these are basically for the rows and columns of the keypad. Then we have while loop for row and column. We initialize row and column from 0. Then we have a for function which is going to run from 0 to 3, basically for 4 times. and this is basically to interface the rows and columns. This program, here we have used a log. This log basically converts these inputs to 3, 2, 1, and 0 respectively. Then we have display function which displays the number to 7-segment display. Then we have store this number to red, and then we have displayed this red to port B. So it is a task 4 or lab 3, and I have shown the Proteus to you. So if we press 2, 2 is displayed on this 7-segment display, and if we press 5, 5 is displayed on this 7-segment display. Now let me show you the hardware. So here we have the hardware videos. So this is lab task 2, in which we are going to monitor port B, pin 5. So this is basically 0, 1, 0, 0. If we press it becomes 1, 0, 1, 0. So it is the hardware video of lab task 2. Then for lab task 3 we have this counter which displays values from 0, then 1, 2, 3, 4, 5, and 6. So it was all about lab 3. Hope you understand. If you have any query, you can comment below in the video. Thank you. Allah Hafiz.